So class, we're on section 12-4, which is adding fractions with denominators of 100 and 10. Now, you're probably thinking, if you're still paying attention, that, hey, we've been working with decimals, so why are we working with fractions? Well, the answer is the book did a very poor job of organizing it. So that's the real answer. What they should have done is they should have made a bigger point of showing how fractions are related to decimals. Because it's going to be much easier to add decimals than it is going to be adding our fractions. Now, look at this number right here. 3/10 and 3/100. Now remember, when we add fractions, if those denominators aren't the same, we can't add them. We don't do that in 4th grade. It's not one of our standards. But we are going to introduce you to it because adding with decimals is going to be much easier if we can remember that these fractions are the same as these decimals. Here's 3/10 plus 3/100. We're in that hundredths place value. And just like always, if you pay attention to yesterday's lesson, we add up the decimals. And just like when we compare, if we add those decimals up, we can just add like a normal number. 0 and 33/100. Now, what does this have to do with fractions? Well, it's pretty easy. We have that saying, whatever we do to the top, we have to do to the bottom. So we need to make these denominators the same. So how do we get from 10 to 100? Well, we multiply by 10. And whatever we do to the denominator, we have to do to the numerator. So we multiply by 10. So what does this fraction become? It's going to become 30/100. And now we can add it because the denominators are the same, 100, 100. So we get 33/100, which is the exact same that we got with this decimal over here. Now, I think personally it's easier to add decimals because I don't have to worry about changing those fractions at all. That's what I think they're trying to go with this lesson, but they did a bad job of it. So our rule for this is the denominators must be the same. And the good news is in 4th grade, you only have to worry about getting the denominators from 10 to 100. In 5th grade, you're going to have to worry about getting numbers like 5, 6, and 7, 8. You're going to have to worry about how to get a 6 and 8 to have that same denominator. But again, we don't worry about that in 4th grade. We just worry about how do we get from 10 to 100 when we add them. So number 1, suppose Jana collected another 25/100ths of their goals. This was from the previous problem in the visual learning that we watched. What fraction of the goal have they now collected? Well, if you remember in the previous part, they collected 45/100ths. And so now we have another 25/100ths. So what would that be together? Well, the denominators are the same, so remember, we can add our fractions back from our fraction unit. 45 plus 25, well, that is 70. And the denominator stays the same. So the answer is 70/100ths. Now, number 2, write a problem that represents the addition shown below, then solve. Well, here I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 9/10, or as I'll do with some of them, it's going to be 9/10, just so we can see how that fraction is related to the decimal. And then here we have 1, 2, 3, 4, 5, 6, 7. So we have 7/10 and 1 left over. So we have 71/100ths, which as a decimal is this. So now what do? Well, we add them up. So we can either multiply by 10, so my denominator is 100, my numerator is 90, and then we can add them, which is give us 161/100ths, which we have 100 hidden in there, so we can pull out one whole, and we're left with 61/100ths. Or as I like to do with the decimals, we line the decimals up. Now we can just add them. We add that 0, because remember, there's nothing there. We can add a 0. 1, 9 plus 7 is 6. Regroup the 1. That decimal just comes straight down. Notice our answers are the same, 1 and 61/100ths. This whole unit 12, is on decimals. So again, I don't know why they switched to the fractions, and they don't tell us how that relates to decimals. So our next part, we have what? Well, we need to multiply by 10 and by 10. So that's going to be 30/100ths plus 4 hundredths, which is then 34 hundredths. Or we can do, 0.04 hundredths, oops, but I did them backwards, plus 3 tenths, which gives us 34 hundredths. Same answer again. So now number 4. Denominators aren't the same, so we need to multiply by 10. And remember, when we multiply by 10, we're just adding a 0. So now 71 plus 50, that's 121 over 100. And we have a whole here, so that's going to be one whole with 21 out of 100 left over. Again, as decimals, this would be 71 hundredths plus 5 tenths, which is 1 whole and 21 hundredths. Over here, denominators are not the same, so what do? We multiply by 10, which means we just add those zeros on. So now we have 3 plus 380, which is 383 over 100, which we have 3 wholes in there, so that's 3 wholes and 83 over 100. Again, as a decimal, we have 3 hundredths plus, what's this? Well, remember, we have 3 wholes hidden in here and then 8 tenths left over, which is 3 and 83 hundredths. Number 6. Again, multiply by tenths. They have that same denominator. So this would be 90 hundredths plus 1 tenth, which is equal to 1 whole. Or we could do it as our decimals. Which I guess I just did as my decimals. If we did our fractions, we would have 100 hundredths, which is the same as that 1 whole. Mr. Wimbley was not paying attention. Number 7. Here, notice how we have 3 fractions. It's no different adding 3 fractions. I had 3 decimals. But with our fractions, they all have to have the same denominator. So we're going to multiply by 10. Multiply by 10. Now our denominators are the same. So what do we have? Well, we have 80 plus 10 is 90, plus 7 is 97. And then the denominator stays the same. Our answer is 97 hundredths. For our decimals, if we wanted to convert them, we're going to do what? Well, we would have 8 tenths plus 1 tenth plus 7 tenths. And like we've talked about before, we would need to line those decimals up. And then we could just add them up. And you'll see we get the exact same answer of 97 hundredths. Now, hopefully you understand how we're doing these decimals and how the decimals relate to these fractions. Because for the rest of them, we're just going to focus on adding the fractions. So our lesson's on adding the fractions. That's what the book wants us to do. But I wanted you to see those decimals. But going forward, we're just going to do the adding fractions. Don't forget, though, how they're related to decimals. So here we multiply by 10. Multiply by 10. Remember, when we multiply by 10, we just add those zeros. And now we can add them up. 38 plus 40 is 78. Plus 20 is what? Is 98. And denominator stays the same, 98 hundredths. Now, number 9. So again, we're just adding these up. But this time, we're actually not adding. We're trying to figure out how we got from here to here. Well, notice we multiply by 10. So whatever we do to the denominator, we have to do to the numerator. 2 times 10 is 20. And then it doesn't tell us to solve it, but guess what? We are going to solve it. So that's going to be 41 100ths. Over here, we have what? Well, these numbers are the same, but we need to figure out how do we get from here to here. Well, that's a little tricky, isn't it? Because I can't think of anything. And you'll notice these two, while they look the same, are not. So, that's right. It must be this one we're going to. So how do we get from 10 to 100? Multiply by 10. So now we need to think, what number times 10 equals 30? Well, that's a 3. And now we can add them up. 30 plus 68, well, that is 98 100ths. Over here, this one's a little tricky too. Notice first number or first term goes with our first term. So this is going to stay a 4. We multiplied by what? By 1. But our next one, we're actually not multiplying. We're simplifying. We're making it smaller. So we divide it by 10. So what do we have to do here? 60 divided by 10. Remember, when we're dividing by 10, if they both end in a 0, that 0 can cancel out. So we're left with 6. And now what do we have? We have 4 plus 6 is 10. And 10 is our denominator, which means we have 10 tenths, which is the same as 1 whole. All right, our next one, number 12. Multiply by 10. So we add a 0, and now we add them up. When we add them, we get 120 hundredths, which that's 1 whole with 20 hundredths left over. Number 13, multiply by 10, Then we have 110 plus 41 is 151 hundredths. We have 1 whole, so we pull 1 whole out, and then we're left with 51 hundredths. Again, if you're still not good with wholes being inside a fraction, those improper fractions, you need to practice that because we have moved on. Multiply by 10. So now our denominators are the same. 72 plus 60 is 132 hundredths. We have a whole hidden there, so we pull 1 whole out, and we're left with 32 hundredths. Just as a reminder, as a decimal, that would be 1 whole and, because that decimal means and, 32 hundredths. We ended in the hundredths, so we need to end in that hundredths. Number 15. Denominators aren't the same, so we need to multiply by 10. And now we can add them up. 50 plus 30 plus 18 is 98, and the denominator stays the same. Since the numerator is smaller, there's no whole hidden inside. Multiply by 10, so our denominators are both 100. 7 plus 60 is 67 over 100. Number 17. Multiply by 10, so our denominators are the same. So now we have 94 over 100, 94 hundredths. Number 18, we're almost done with this, just a lot of repeated practice. Multiply by 10. Remember, when we multiply by 10, we add those zeros on the end. 30 plus 50 is 81 hundredths. Number 19, multiply by 10. 39 plus 20 is 59 100ths. Number 20, multiply by 10. So now my denominators are both 100. 80 plus 9 is 89 100ths. Denominators aren't the same, so we need to multiply by 10, so they are. 44 plus 34 plus 90, well, that's 168 100ths. And we have a hole in there, so we're going to pull 1 whole out, and we're left with 68 100ths. 22. 70 tenths plus 33 hundredths. Multiply by 10, so our denominators are the same. We have 733 100ths. Notice we can pull 7 groups of 100 out. So we have 7 wholes with 33 hundredths left over. Number 28, our denominators aren't the same, so we need to multiply by 10. Now what do we get when we add them up? Well, we actually get a ginormous answer. We get 1,084 hundredths. Now, how many wholes do we have here? Well, if we count by 100, we have 100, 200, 300, 400, 500, 600, 700, 800, 900, 1,000. So that's 10 groups, 10 wholes we can pull out. And then we have 84 hundredths left over. Woo, that was a lot of practice problems. Hopefully you guys are excellent at those now. So now we'll head to our word problems. A mail carrier made a total of 100 deliveries in a day. 76 hundredths of the deliveries were letters, 2/10 were packages, and the rest were postcards. Write and solve an equation. Where'd we go? Write and solve an equation that represents how many of the deliveries were postcards. So what do we have? Well, we have 76 hundredths, and I'm just going to label that. Those were letters. And then we had what? We had 2/10 were packages, so I'm going to label that P. And the rest were postcards. So we're just going to put cards, but this is our question mark. And what does that equal? Well, remember, we're fractions, so we need to figure out a whole, 100%. So we need to figure out how do we get 100 hundredths. Now, since it does say equation, we don't use question marks. Remember, with equations, we use letters. So those letters are the exact same as a question mark. It's just more mathematically correct. I'm going to use C for that question mark, standing for postcards. So we need to figure out what C equals. Well, first, we need to do what? We need to multiply this by 10. 10 tenths. So that's going to be 20 100ths plus C equals 100 hundredths. So then what do we have? Well, we have 96, and I guess I'm going to have to slide this up here. 96 hundredths plus C equals 100 hundredths. So now I need to figure out 96 plus what equals 100? Well, that's going to be C equals 4 hundredths. Because look, if I put 4 in here, that's going to equal 100 100ths. So 4 tenths of the postcards, or 4 tenths of the mail deliveries were postcards. Honestly, much higher than I think it would be in real life, though. Now, for number 25, balloons are sold in bags of 30. So just a reminder, here's a bag. There's going to be 30 balloons in this bag. There are 5 giant balloons in each bag. How many giant balloons will you get if you buy 120 balloons? So, in here, there's going to be what? There's going to be 5 giants, which if there's 5 giants and 30 total, that means there's going to be 25. Oh, because I'm on the eraser. There's going to be 25 non-giants, or we'll just say normal. They might be small, they might be normal size, but we're just going to say normal. So 5 giants, and how many normal? 25. Now we're trying to get to 120. So let's look. This is a group of 30. Here's another group of 30, which would be 60. Here's another group, which would be 90. And here's another group, which would be 120. So what does that tell us? Well, there's going to be 5 giants in this one, 5 giants in this one, and 5 giants in this one. So what do we have? We have 5, 10, 15, 20. There's going to be 20 giant balloons. Now, we could leave this picture as an explanation, but I'm also going to write it out for us. So we're going to write it out like this. Since 30 plus 30 plus 30 plus 30 equals 120, I need 4 bags of balloons. And oops, I forgot. There we go. 4 bags of balloons. 4 times 5 equals 20. So I will get 20, and I guess we're going to write on our face, large balloons. All right, let's head to 26 now. The first 100 elements on the periodic table. So what is this periodic table? I don't know. We haven't talked about it in 4th grade. I actually do know. It's all of the elements, or all the things that make up everything in the universe. So again, not something we've studied, so that's your simple answer. But we don't need to know that to solve it. So of the 100 elements, so there's 100, 13 hundredths were discovered in ancient times. 21 hundredths were discovered in the Middle Ages. Another 5 tenths were discovered in the 1800s. What fraction of the first elements was discovered after the 1800s? Well, first, we need to figure out how many have been discovered before the 1800s, and then see how much is left. So that means we have to add them all together to see how many have been found. So we have 13 hundredths plus 21 hundredths plus 5 tenths. And then what does that equal? Well, we have this problem. We need to multiply by 10. So we get that. And now we add them all up. And what do we get when we add them? Well, when we add them, we're going to get 84 100ths. And now we need to figure out that missing part. So we have 84 100ths plus a question mark equals 100 hundredths. Because remember, 100 hundredths is what? Is the total amount. It means we filled up this whole entire table. So since we are all excellent math scholars, though, we don't use that question mark. Remember, we use a variable. So we're just going to put a P for periodic table. So what does P equal? 84 plus what equals 100? Well, 84 plus 16 hundredths equals 100 hundredths. And for this one, our explanation, since we did our writing up there, we're going to leave our math as our explanation down here. For number 27, our last one, Delia knocked over 7 out of 10 pins in the first frame of bowling. So as a fraction, what is that? That's 7 out of 10, or 7/10. The next 9 frames, she knocked over a total of 67 more pins out of the possible 100 pins of the game. So that also sounds like a fraction of 67 over 100. Delia wanted to find the fraction represented the number of pins she knocked over in the game. Her work is shown below. Is Delia's work correct? If not, explain her mistake. So they're asking, is this correct? Well, let's check. We have 67 here. We have that 7/10 here. And that looks like she multiplied 10 over 10 to get 71 hundredths. So it sounds like it's correct, doesn't it? But here's our problem. And it's a sneaky one. This is what you're going to see on your SBAC. It goes all the way back to this part over here. This is just the first frame, 7 out of 10s. Now, she's not done, is she? She still has to bowl a 90 more. There's 100 possible pins. So her answer for this first one is actually 7 out of 100. Her first time bowling, she only knocked 7 out of 100 total. So how are we going to phrase that? Well, we're going to say Delia knocked over, and I'm going to zoom in for us. Seven out of 10 pins in the first frame. But what? But 7 pins is 7 100ths of the total pins in 10 frames, not 7/10. Remember, she's bowling 100 times, or there's 100 pins, not just 10 pins total. Delia should have written the equation 7 100ths plus 67 100ths equals 74 100ths. Now, if you got that without watching the video, excellent job. If you didn't, that's perfectly okay, because this one of the harder ones we've probably done all year. But one of the things you should notice, which we always say, does your answer make sense, is you should notice right here, does that make sense? That means we'd have 1 hole and 37 100ths. That means she's knocked over more than 100 pins, but there's only 100 pins for her to start with. That means she would have had to had her like bowling ball roll down, knock the pins over, and then it like bounced over into the next lane to knock more over. Because remember, she only had 100 pins that she could knock down. But here we're saying she knocked down 137. So always check and think, does my answer make sense?